So now we will have to solve the same question using the method of choosing a reference axis. So this was the first method. We did case 2 separately, and then case 3, equations for case 3, and then we wrote case 1, case 2, case 3 and solved the equation separately. Now, how do we approach this using a reference axis? The first thing to do while choosing a reference axis for solving problems based on, for choosing a sign convention would be to assign an origin. So you can choose any point in the setup as origin. You can choose B as the origin, or you can choose A as the origin, or you can choose the maximum height as the origin, or any other point. So for the ease of calculation, I will consider A to be the origin here, which means every measurement that I make will be with reference to A. So the origin, I think I should better write it down. So the origin here is made with reference to the point A. Okay. Now, anything above A, I consider that as positive. Anything below that will be considered as negative. Now you can choose the other way around as well. You can say that anything above A is negative, or anything below A is positive. That's up to you. That's a personal point choice. Now, what I want you to do is, I will do this question using above A as positive and below A as negative, and you will write down, not this method, you will write down the same calculation that I do by replacing above A as negative and below A as positive. Okay, I hope that makes sense. Right. So let's see. So when the ball is projected vertically upwards, initial velocity is upwards, therefore it is positive. Acceleration due to gravity is acting downwards. Why? Because it is acting always downwards, so that will be negative. Displacement is acting downwards. Why is displacement downwards? Because B is the final position, which is below A, and therefore you have one value as positive and two as negative. Yes, I do understand that you might need some further explanation on this, so I have written something over here so that you can make note of this, and we will go through the reference one more time. So initial velocity is upwards, right? Initial velocity is upwards. Why? Because the ball is thrown upwards, and therefore the sign is positive. Why is it positive? Because we have assumed that anything that goes up above the point A is positive. Acceleration due to gravity is negative. Okay, it is negative. Why is it negative? Because the gravity always pulls towards the earth. Displacement is negative. Let's mark that as well. Displacement is negative. Why is displacement negative? Because the final position is below the initial position or the origin. Now final velocity will also be negative. Why? Because if the final displacement is negative, the final velocity has to be proportionately negative, and time is always positive as it goes only forward, right? So that's that doesn't make sense. Yeah. So when you take down note, as I said, the corresponding signs will differ here. Why? Because you consider this to be negative and this downward moving values to be positive. So make sure you write things accordingly here. Okay, right. So I hope that makes sense. So in this part, direction of initial velocity is what? It is positive. Direction of displacement is what? Negative. Direction of acceleration is also negative. And therefore, if you consider S is equal to ut plus half at square, right? S is negative h. U is positive u. A is negative minus g. So the equation transforms to minus h is equal to ut1 minus half gt1 square. Yes. Little more doubt? No problem. Don't rewatch now. Just continue with case 2. Things will become very clear. So case 2, object is thrown, it is projected downwards, it is projected vertically downwards. So since it is projected vertically downwards, the initial velocity would be downwards, acceleration due to gravity is pulling it downwards, the final position is below the original position, and therefore all three values will be what? Moving upwards is positive and moving downwards is negative. So all the values would be negative. Okay, hope that makes sense. Let's try to make more sense out of it. So the body is thrown downwards, therefore initial velocity would be acting downwards. Since gravity always pulls the body towards the earth, acceleration is also negative. Why? Because the body is being pulled downwards by the gravity. Final position is below the origin, because this is A. Let me just write down the final position. This is A, position A, and this is position B, which actually refers to the ground. So final position is below the origin, and therefore the final displacement is negative as well, and therefore that will be the same case with what? Velocity, which means all values here are negative. And how will that transform the equation? Let's see. So S is negative h, U is negative minus U, A is negative minus G. Therefore what we get is minus h is equal to minus UT2 minus half G, not T square, half G, T2 square. I think by this time you should be feeling confident in the reference axis, but yet this time you will say along with me. So initial velocity downwards and therefore negative, displacement downwards and therefore negative, acceleration due to gravity acting downwards, therefore negative. One more time. Well, there's a minor error here. This is not thrown, this is dropped. So one more time. Initial velocity is towards downwards. Acceleration due to gravity is always downwards. Final position is below, so it is always downwards, and so will be final velocity. So again we have a case where all the values are negative, which means if we write the equation, what would that be equal to? Displacement, which is minus h is equal to U, which is minus ut plus half into minus dt square. So we have minus h is equal to, now this term vanishes. Why? Because since the ball is dropped, u is equal to 0, and therefore what we get is h is equal to minus half gt square. Right? Now the algebraic calculation remains the same. We got three cases, case 1, case 2, case 3. Now this is where you will go back to the previous solution and you will compare the difference in case 1, case 2 and case 3 by choosing reference axis method 2 with that of along the direction as positive and against the direction as negative, that is method 1. And you will write down these equations here, case 1, case 2, case 3, and then you will understand the difference in applying this. See, once you are clear with this, choosing the reference and choosing the sign convention, relative velocity, and for that matter, almost every topic in the upcoming topics in this chapter would be, a piece of cake for you. Okay. Right. So yes, now we have three equations, and if you notice here, the LHS of these two equations are the same, which means the RHS can be equated. So as I said, the LHS are the same, and therefore RHS can be RHS can be equated. So we have UT1 minus half GT1 square is equal to minus UT2 minus half GT2 square, which gives us transposing minus U2 minus UT2 becomes plus UT2 minus half GT1 square becomes plus half GT1 square. I can take U as a common term from these two terms in the LHS, then half G as a common term from the RHS, which gives us U into T1 plus T2 is equal to half into G into T1 square minus T2 square. Now, T1 plus T2, T1 square minus T2 square can be expressed as T1 plus T2 into T1 minus T2. T1 plus T2 by T1 plus T2 is 1. Therefore, what we get is U is equal to half G into T1 minus T2. We already have the equation minus H is equal to minus half minus GT square, and from the case 1, minus H is equal to U T1 minus half GT1 square. We'll combine these three. We'll substitute we'll substitute the value of this U over here, and we'll plug in minus half GT square over here. And then what do we get? Minus half GT square is equal to half G into T1 minus T2 into T1 minus half GT1 square. Now, since 1 by 2 G is 1, 1 by 2 by G is 1, 1 by 2 by G is 1, all what we have is minus T square is equal to T1 into T1 becomes T1 square, T1 into T2 becomes T2 T1 minus T1 square. Opening the brackets further, T1 square minus T1 square, T1 square minus T1 square is 0. So we have minus T1 square is equal to minus T2 T1, and therefore T square is equal to root of T2 T1, or T is equal to root of T2 T1, which is the correct answer. Okay, so one question, two different methods, two different sign conventions, we arrive at the same answer. Now, this should clear almost every possible doubt which you have in selection of sign a suitable sign convention for solving questions based on motion and gravity. All right. So, as I say this in every possible solution, make sure you go through the solution one more time, watch it one more time, write it down one more time, close the solution, then try to do it on your own. Write it as detailed as possible. Write it every step, copy down every step that's possible, and try to do that a couple of times. And once you make that as a practice, then the swiftness of solving the questions, the speed by which you solve the question, it increases gradually. It comes to you very naturally. All right. Okay, so the next question again is one which is based on relative velocity, and this is a very important question because see, this is what I say, the JEE Mains will not just test your numerical skills alone, it will also test your, well, of course, the patience you hold in reading the question, understanding it, but most importantly, the concept behind the question. All right, so let's see.